Algebra 2 is glad you're still here. Here's homework 2-4, page 2. We've got some factoring to go, so you ready? I see 4 terms. As soon as I see 4 terms, I'm going to get my associative property. Associative property. Able to group things any way I want. Alright, he's like a superhero, I swear. Alright, so looks like 2 x's can come out. And we're going to have 1 x left plus 3. And then it looks like we're going to take out a negative 4, which is going to give me 1x plus 3 is equal to 0. Uh-oh. I see where this is going. Do you see what I see? So in fact, we'll divide out our happy face. Now do you see it? Ah, difference of squares. Here we come. So x plus 3 comes out, leaving me with x squared minus 4. And by the way, it's all equal to 0. What we have to do is anytime we're left with something other than a variable or an exponent of 1 on our variable, we have to see if we can keep factoring. So this is a difference of 2 perfect squares. And I know it's going to factor into plus 2 minus 2. So guess what? We're going to remember this factor too. I have 1, 2, 3 possible answers. Well, that makes sense because it's a cubic. So a cubic graph is one that goes like this, and this one happens to cross the axis. If this were an axis, 1, 2, 3 times. Where does it cross, you ask? I don't know. X plus 3 could be equal to 0. So it crosses the first time at negative 3. How about this? X plus 2 could be equal to 0. The second time it crosses is at negative 2. And guess what? X minus 2 could be equal to 0. The third time this graph crosses is at 2. So this graph crosses each of these 3 times. That's my zeros, my roots, my zeros, my solutions. All right, let's take out a 2 and see what we're left with. I'm curious. Yep. It's a difference of squares again. Now, because there's no coefficient here, I can go ahead, or there's no variable here, I can divide that out. And I'm looking at x squared minus 16 could be equal to 0. So now I'm looking at x plus 4. X minus 4 could be equal to 0. X plus 4 could be equal to 0. X could be negative 4. X minus 4 could be equal to 0. X is equal to positive 4. Those are my roots, my zeros, my solutions. The place where this graph crosses, the x-axis. Ooh, we got a big GCF here. Does 6 go into 150? I know it goes into 10, but we'll go ahead and double check that. So we'll have 150 divided by 6. How many times? 25. So we're definitely taking out that GCF. X squared minus 10x plus 25. I see a special pattern. Here's my square, double square. And guess what? We don't need this 6 anymore. He's not a variable, so see you later. So my x squared minus 10x plus 25 can be equal to 0. Do you see the square, double square pattern? Perfect square trinomial, perfect square binomial, which means I really only have to do this math once because this 5 is what we call a double root. And if it's a double root, that means that this graph just sits on this axis at x is equal to 5. All right, we definitely have some GCF conversations coming our way for this one. So we're definitely taking out a negative 3, and guess what? I think we can take out an x too. So that's going to leave us with x squared minus 7x, and then minus 3 goes into 90. It looks like 30 times is equal to 0. Now guess what? We can't just divide this guy out because he's got an x. So this is going to be one of our answers. We need to hold on to him. So negative 3x stays, but let's go ahead and factor this. X splits into x and x. Now let's talk about negative 30. 30's factors are 1 and 30, 2 and 15, 3 and 10, 5 and 6, and there's my wraparound. Any one of these have a difference, and I know it's got to be a difference because that's negative, so my signs are going to be opposites. A difference of 7. Here we go. Now ask yourself which one's negative. I have more negatives than positives, so my greater value has to be negative. And now I have 1, 2, 3 little mini equations I need to solve. Because guess what? 3x could be equal to 0, which means x could be equal to 0. X plus 3 could be equal to 0, which means x could be negative 3. And x minus 10 could be equal to 0, which means x could be equal to positive 10. All 3 of these are zeros, roots, solutions. All right, mixed review, factor completely. Now notice, no equal signs. So I'm not solving because how come? No equals 0. They don't have an equal sign. These are just expressions. Difference of two perfect cubes. So I know that 729, I think, let's verify that. Is that 9 cubed? Yep. 9 to the third power. Oh, there we go. 9 to the third power. Definitely. So for this one, we're going to have my A value is x and my B value is going to be 9. So I set up my binomial, trinomial, and I have the same sign, the opposite sign, always positive. Remember our SOAP. So I have x minus 9. Here's x squared, a squared. Here's b squared, and then a times b goes in the middle. Remember, this is always prime. It looks like you should be able to do something with it, but you can't. We have another, but instead of a difference of cubes, now we have a sum of cubes. My a is going to be 2x, because I'm going to take the cube roots. My b is equal to 1. So when I do my SOAP, I'm going to set up my binomial and my trinomial, and I have the same sign, opposite sign, always positive. So I have my a and my b, my a squared, my b squared, and my a times my b. And again, this looks like you should be able to factor it, but you can't. That trinomial is always prime. The sum of squares, because it's a sum, and because that's a square, it's prime. You can always just go ahead and say that. All right, I see 4 terms, so associative property. So we'll go ahead and factor out, definitely, look at all those y's. So y cubed is coming out, and that's going to leave me with 3y minus 4. Factor out a negative 1, and that's going to give me a 3y minus 4. There's my happy face. So 3y minus 4 times y cubed minus 1. Uh-oh. Here's a difference of cubes. So my 3y minus 4 is my 1 factor, but guess what? Now I have a binomial, trinomial, and I have to go use some SOAP. Same sign, opposite, always positive. My a was equal to y, and my b was equal to 1. So I have y squared minus 1. My a and b go in here. That's not squared. Here's where y squared goes. Y squared. A times b is just plain old y. And then 1. Same sign, opposite, always plus. Let's check this out. 343, is that one of our perfect cubes? Let's see. The best way to figure that out would be if I went ahead and said x to the third power, and then I could look at my table and I could see, hello perfect square, or perfect cube. So I know that both of these check out as perfect cubes. So A is going to be 2t, and B is going to be 7. So here we go. Binomial, trinomial, and let's use some soap. Same sign, opposite, always positive. And my A goes here, and my B goes here. Here's for A squared, B squared, A times B. Perfect. All right, I see 4 terms. Da-da-da-da-da. Associative property. Able to do what? Group with things any way I want. So let's go ahead and pull out a common factor. 68 and 8 are not friendly numbers. I know I can take a 4 out, but guess what? So this R comes out, so does a 4, and that's going to leave me with 2. So 2 of those R's came out. It's going to leave me with 2 and R minus, so 68 divided by 4 is going to be 17. 2 minus 17 plus R minus 8. Guess what? This guy doesn't factor. No happy face. So as soon as I find that, we write prime. Let's try this one. 1, 2, 3 terms. Let's pull out these common factors. Holy cow, these are messy. So it looks like a negative 4 comes out of both. All 3. Just one x is the maximum I got. And how many y's? I can take out 2 y's and no z's. So let's see what's left. A positive 2 and 2 y's are left on my first term. My second term is going to be a negative 5. 1 x is left, no y's, and that z is left. 4xy squared. Whole thing comes out, so that becomes plus 1. That space holder matters. Difference of 2 perfect squares. So even though 64 is also a cube, we don't care about that right now because we're dealing with the second power. So I have w plus 8, w minus 8. Difference of squares. All right, good job. Thanks for sticking with me.